Okay, YouTube, in this last video we're going to explore what we call an infinite geometric series, which is really just the sum of an entire geometric sequence, okay? So if we were to say we had some sequence here, some first term, and then first term times r, and times r again, we have some geometric thing where basically we're just taking this times r every time. But if we were to add up not just, the first n terms of this, but like actually all of them forever and ever, sometimes you can have actually what we call a finite sum. So we say not just any sum, a finite sum, which means you could add up infinitely many numbers and actually get a number that you can count, okay? So there is one stipulation on this, and we are going to mention that here, but we say the absolute value of r has to be less than 1. In other words, what we're saying here is this. We say if the absolute value of r is less than 1, we're saying that r is some number between -1 and 1. And basically what we want to do is we want to comment on this. It is a proper fraction. So for those of you who need a little review here, a proper fraction is any fraction a over b where a is less than b. That is, the top is smaller than the bottom. So imagine this. If you had a rate or a common ratio that you were taking some first value times, but you were smaller than 1, or a proper fraction, basically the thing you're getting for the next term would be smaller than what you started with for the first term because you're taking it times a number less than 1. So if you keep doing this, you might have a sequence here that maybe like you start with 4, but you take it times a half, which is a half is less than 1. You'd have 2, and then you'd have 1, and then you'd have a half, and then you'd have a fourth, and then you'd have an eighth, and you notice that these numbers, they just continue to get smaller and smaller every time. If we were to actually find the sum of this entire series, you actually come up with a finite value. So that's what we're going to explore here. And basically, let's point out a few basic facts. We write the sum as just s. Previously, we had said s sub n, where this is the sum of the first n terms. That's what this would be, n terms. So that's what s sub n is. We just write s. We don't have to write s infinity, but that's basically what we're inferring here. I want to add up all of the terms of this series right here. We say that our first term is a1, and then we have r to the n minus 1, okay? If that is our rule, which is that's all I want to point out here, then we say we need to know these things. We need to know the first term. So we say needs. We need a1, so the first term, and we also need this. We need r, so we need the common ratio. And you notice we do not need the number of terms that we're summing this time because it's just very, very general, all right? So we'd say, all right, if we want to find this here, we say it's a1. Oh, sorry, did I point out n here? We need r here. I meant to point out r here, not r here. So we need these things, essentially. So this is very common and actually very similar to finding the sum of a finite series. It's just that the top is a little bit more simplified, okay? So we'd say, looking at this says I want to go find the sum of this series right here. We say the sum of this rule. So keep in mind that our a1, we need a1, that's our 4 right here, and then our r is 0.6 it seems, okay? So we would actually get this finite sum, and it says that if we want to use this rule here, it's 1 minus r, and then we'll just stash our a1 here. So our a1 is 4. We're going to go plug that in. We say 4. And then we say that this is 0.6. So to find this sum, actually, we just say it's 4 over 1 minus 0.6, which is 0.4. Which, by the way, would be the same thing as 40 over 4 if you slid your decimals. But the point here is, you get 10. So we'd say adding up the first, or infinitely many terms of this thing, not the first however many, but all of them, you would actually get a finite sum, and it comes out to be 10. Okay. So taking a look at this again, we say, could we find this infinite geometric sum? And actually, we can in this case, but the way I want to point this out here is this. We say r is equal to a half, and that is between -1 and 1. So we are multiplying by a proper fraction this time. So we'd say if we went and added up all these terms, that is, if we added up 5 plus half of 5 plus half of half of 5 plus, half of half of half of 5, 0.625, I think is what that would be. The whole point of this would just be that if we added up all these terms forever, we could find this infinite sum. So we need our first term. Again, we need our first term here, which is just 5. It's over 1 minus r. In this case, our r is a half. So we really get 5 over 1 minus a half is a half. And when you divide with fractions, you really just multiply by the reciprocal here. So we get 10. So this also has a sum of 10 when you add all these up. But that is how you find an infinite geometric series. Cheers.